Hello, I am an Egyptian. I am looking for the tomb of King Tut. Can I find that here? No, sorry about that, Egyptian. We're just talking about science. Okay, I will be on my way. Well, that was strange. Let's talk about streams. You know, like little rivers. Stream, by definition, is when you have rain flowing down a mountain that gets into a channel. And you can imagine this. You have rain that is going down a hill, and it will tend to collect with other in the lowest parts of the way down the mountain, and it will collect with other parts. And that's where streams start. Streams generally start in the mountains. Another term, this land, with this mountainous land where water drains into a stream, is called a drainage basin. Now, I say it's mountainous land, but it starts out as mountainous land, but all it has to be is higher than the river for it to be a drainage basin, because you can have a drop of rain that falls near the top of the Rocky Mountains and it can flow in streams and rivers even onto flatter land. In most drainage basins, water eventually flows to the sea. Now, some of it is going to be soaked up by the land and end up out in the stream or a river in a different way. But for the most part, you take those water droplets, they will eventually, for the most part, end up in the sea. Drainage basins are separated by ridges called divides. Now, I'm going to show you a picture of the most famous divide we have here in the United States. And let me remind you, we have a lot of terms that have to do with erosion, so try your best to distinguish between things like divides and drainage basins. Here is the most popular or most widely known divide in the United States. It's the Continental Divide. And what you have here is the very top of the Rocky Mountains, and the Sierra Madre Occidental Mountains is in red. Pardon me. So if you have rain that falls to the right of this red line, it will eventually flow into the Atlantic Ocean. If you have rain that falls to the left of this red line, it will flow to the Pacific Ocean. It divides the two drainage basins. We have a big drainage basin over here that goes into rivers like the Mississippi River, the Missouri River, even over here at the Coosa River. And we have off to this side this big drainage basin that goes into areas like the Colorado River and rivers that would flow into the Pacific Ocean. Hey, more terms. A floodplain is the lower areas on either side of a river. Now, you typically have pretty good farmland in floodplains. Unfortunately, it floods sometimes. And the reason it's good farmland is because sediment dropped on the floodplain makes it that way, makes it very fertile. It just kind of turns out that soil that has been picked up by one place and deposited elsewhere, when they pile up together, they generally make fertile land. Already has a lot of good pore space because it's soil in the first place. Another term is a meander. Meander is curves and bends in a river, and rivers tend to not flow perfectly straight. And it's something you might not realize if you were to just stand on the edge of a river and look up one way and look down another way. Generally, rivers, when you look on a map, have big curves or meanders in them. Even the Coosa River, the one that's so close to us, and when you look on a map, has these big meanders in them. Here's an overhead picture of one. You can see we have this big curve here, and as it goes on that way, it has more curves and more curves and more curves. Here's another one. Oh, good looking at meander right there. And here's another one. And that's just kind of the way rivers are. Now, these meanders end up creating oxbow lakes. These are curved lakes near a river. Now, let me go back to this meander right here. What happens if you get a lot of rain and it starts flooding? You have this thin area here, you have this thin area here. What if the floodwaters get over this? get over this, and you have the stream which is going in a particular direction. Could the stream end up going over these little parts? It certainly could. And that's how oxbow lakes are formed. And here's an example of one. Look here, we have the river which is going this way, and we have this little lake that has been cut off from it. This lake that has been cut off from it is an example of an oxbow lake. Here's another example of an oxbow lake. Look at the main river here, and you have this oxbow lake right here, which has been cut off. You can just imagine at one point this went here and kind of curved around here and went there, but there was a flood at some point, and the current started going over that way, just skipped over that area. And that could definitely happen right here too. I mean, you could have that current which has a flood, in a flood situation, would just kind of skip over that and end up making another oxbow lake. Let's talk about another couple of terms. We have alluvial fans and deltas. An alluvial fan is at the base of a mountain, and it's where rainwater has left sediments there. Now, if you have rainwater that comes to the top of a mountain, it will wash down a mountain, and those sediments have to go somewhere. And sometimes if you have the base to that mountain, sometimes you have a fan shape where all those sediments are. And I'll go ahead and skip over delta, and we'll get back to that. Oh, here's an alluvial fan. See what we have here, you see this kind of groove where water just kind of, rainwater just kind of washes down, and all this sediment that the rainwater takes with it has been deposited over, no telling how many years it took to have an alluvial fan this big. An alluvial fan, well, it kind of looks like one of those old-fashioned fans where you fan yourself. Oh, let's see what we have here. Oh, here's a delta. Let's go back to the term delta. At the bottom here, you can see a delta is where the river enters the sea. Now, if you noticed at this delta here, the river is going straight until it gets close to the sea. And what happens is it kind of makes a little crow's foot here. It travels in all different directions. And the reason it does that is all this area right here, that's sediment. No telling how many hundreds or thousands of miles this river flowed, and carrying with it all the way sediment. And generally, when it finally does get to the sea, it will drop the sediment as it goes into the ocean. The sediment just doesn't flow with it all the way into it. All this is sediment, the rocks, the weathering, and that's what happens when the sediment is dropped. Suddenly you have this river which flows right into that, and it will end up taking its way around the drops of sediment. So all of these little forks, what you might say, are the way the river is getting around the sediment. Let's see if we have another one here. Oh yeah, there's a good one right here. We have this river which is in Louisiana, and I'm not even going to attempt to pronounce it. But we have this river here which comes, and all this area here kind of looks like an alluvial fan, the base of a mountain, but all this land here is sediment. All that land is sediment, and you have the river which has to kind of make its way around the sediment. And this sedimentary areas, or sediment areas here, I mean, people live on these sediment areas. It's not like it was just formed the other day. This was formed many hundreds of years ago. And as a result, I mean, it has grass growing on top of it. It has sand, which is kind of there, but a lot of beaches are on delta areas.